Howdy. Extinction Rebellion activists glue themselves to Picasso painting. Climate chaos, war and famine. Extinction Rebellion said no art was harmed in the incident, which saw protesters glue themselves to a Picasso painting. Two climate activists with Extinction Rebellion were arrested Sunday after gluing themselves to a Picasso painting at the National Gallery of Victoria in Melbourne. The activists glued themselves to the glass covering of Picasso's massacre in Korea, standing alongside a banner that read, "Climate chaos, war and famine," highlighting the connection between climate breakdown and human suffering, the organization said on Twitter. "If we continue on our current path, we will face the collapse of everything that gives us security, leading to conflict," the group said, quoting naturalist and TV host David Attenborough. Victoria Police said they believe the protesters entered the group level of the gallery before a man and a woman glued themselves to the covering at around 12:40 p.m. local time. The 49-year-old woman from the state of New South Wales and the 59-year-old man from Melbourne's suburbs were removed from the painting just after 2 p.m. The two were arrested as well as a 49-year-old man, according to Victoria Police. What? They arrested some random dude? Extinction Rebellion said no art was harmed in the incident. Climate change is on course to transform life on Earth as we know it. And unless global warming is dramatically slowed, billions of people and other species will reach points where they can no longer adapt to the new normal, according to a major UN-backed report released this year. Based on years of research from hundreds of scientists, the report found that the impacts from human-caused climate change were larger than previously thought, with the report's authors warning these impacts are happening much faster and are more disruptive and widespread than scientists expected 20 years ago. Those who contribute the least to the problem are the worst affected, experts added in the report. Okay. I created this funny little picture here. Earth's atmosphere over time. So we have different timelines here. Here we have billions of years. And this is CO2. And then it goes beep, a little bit up here at the end. Which is probably also the moment we started to measure the whole stuff. So, but as you can see here, it has been much higher back in the old days when we had dinosaurs. And they obviously thrived. Furthermore, we have to take into account cosmic cycles. I show them just in the recent videos or video. And Earth's electrical environment. For those who have seen my videos about this is a surface conductivity anomaly over Scandinavia. Here is the Kursk magnetic anomaly. And I think they will affect more and more weather, as is seen here in this radar picture. and I've done videos. You can find them in the playlist list. Temperature fluctuations over time on Earth thousands of years ago. So we are talking about 100,000, 200, 300,000. So you get it. And obviously it went up and down, up and down, up and down, up and now it goes up. And every time it rose sharply and dropped quickly. Otherwise we would have a wave. But we don't. Holocene temperature variations. And here we talk about thousands of years. 2,000, 4, 6, 8,000. Just for comparison, above we have hundreds of thousands of years, and here we have just thousands of years. And obviously, back in the old days, it was slightly warmer than it is today. But before, it has been also colder. So one could ask, what's the big fuss about the little temperature variation from 2 degrees, 3 or 4, compared to bigger variations? And we are just watching at 12,000 years. So there is a huge difference from almost 8 or something, how much it is. I guess it's 8 because we have the number 8 and minus 12. So there's many degrees of variations. And if Earth has done this ever since, how is it possible that all of a sudden we are blamed for it? You know, there hasn't been anyone driving around with an SUV 400 million years ago. I don't know. It's very interesting. But I have been now loading in the meanwhile the volcano application, like the quakes of the last 7 days, because there has been a deeper quake in the Alps. Let's check it out. Like, you know, almost like trying to entertain you. Here has been a deeper quake 5 hours ago near Gap 1.1, depth 29 kilometers, which is already quite deep for being in the Alps. And how can it be? If you just look at the region here, we zoom out a little bit closer maybe. There seems to be some white rivers in the proximity of the quake. Yes, it is gray, I know, a dark white. And that, if you zoom in a little bit, we end up at a well source spring. Let's try to measure. I don't really trust in the exact place of those quakes. They can differ by hundreds of meters. Let's say 50 meters from this well, and how accurate this well map is anyway. But probably very close to a spring. And there's water all over the place. Like all over the place. Literally. Very interesting. But not too surprising. And you can see the patterns from space, dendritical patterns. Some of these are quite likely also created by just weathering. There should be in the proximity very many quakes. Let's turn it around. I got to orientate myself first. Where's the yellow one? Barcelonete? We aren't. Monvisa. Just to tell you, here is Monvisa, which is the source of the River Po. And the River Po is Italian's largest river. Starts somewhere here where we have the quakes, and it goes all the way here. And all these drain into that river. My Rice Krispies are growing there. So let's see how many packets they have still in stock before they end, because they probably won't come any Rice Krispies anymore after that. Which is a really sad thing. I like them. And there is this little village, Maddalena. That's the wrong mountain, actually. Where is Monvisa? Barcelonete. Monvisa. All right, Maddalena. Here. A few weeks ago, there has been many quakes in this region, on this mountain and also on this other side. And there has been a swarm, I would say. And there are interesting features on Mount Visa or Mont Visa or however you want to call it. There are several of them. Like these kind of things. They look rather interesting. They almost look like something would have once poured out of the mountain. Or maybe it just slipped down. I don't know. It seems like. But the reason why I think there could probably something have been pouring out, because there is a new one. And maybe this channel is so deep because there is a constantaneous flow of water from somewhere, probably from this area here, where it is darker, because it might be darker just because of its wet. There's just water coming out of the rock, mountain water, and it somehow appears to be rather light or white in color. Yeah, I was hoping to see much more quakes in the region, but there haven't been. But that's another hotspot that somehow they transferred here. What is it again? Grand Juras? Mer de Glace? Mont Blanc. Let's call it Mont Blanc. The highest peak of the Alps, with some rather interesting glacier features. Check it out. Very interesting. I've been talking about this many times, also about these quakes. And for example, let's take those two, which aren't two, there are many more. Because if you click once, 1.27 days ago, you try to click again, 1.03 days ago, 0.57 days ago, that's the third one. So we have three here. 1.27 days ago, 0.95 days ago, 0.75 days ago, that's the third one, 0.75 days ago, fourth, 4, 3 and 4, 7 quakes. And if they would be totally accurate, I mean the position of those quakes, we could maybe assume that there is a well or something, an aquifer being activated. Who knows? I don't think it would be too much to think about this. What's up with this waterway? Just starting here at the edge of Mer de Glace, at the edge of the glacier. And it just goes there. Check it out. There's ice again. This might be icy under this brown. Let's just follow this track here. I think we will end up sooner or later at the glacier. No, we don't. We go alongside of it. Very interesting. And look at these different colors of sediment. That's darker than this one. Then it's a thinner layer, and then we have a rocky layer, and then we have a white stripe, and a darker layer, another dark white stripe. How so? I don't think that any glacier carved any valley out ever. There has been a quake here 7 days ago. Yeah, this would be very interesting places to take a hike. Checking out these places, like, for real. I really appreciate all those satellite images and stuff what you can find nowadays. Otherwise, it wouldn't be possible at all to take a look at these things. But like, going there would be a whole different thing. The closest that you can do with internet is searching pictures of the regions. And that might be also a place where something might come up from underneath, which might also provide some warmth every now and then, according to its own fluctuations. But anyway, I just wanted to tell you that Mont Blanc, White Peak in English, and these glaciers here, there is something really going on. And we are in the middle of the Alps. Chamonix, there's actually a deeper quake. Check it out. 7 days ago, 14 kilometers. Yeah, not that deep. And here in Austria, no, that's still Switzerland actually. 50 kilometers. Let's just take a quick look at that. And we have glaciers. We have GOMS, Obergoms, and GOMS. There has been a huge rockfall, mudslide, or whatsoever some years ago. If I remember, I make once a video about that. The fire horn. Yeah, but it's not English. It's another language. These are just shadows. I thought first these are water bodies, but we have water veins. Here is a water body. Check it out. Rundsee, the round lake. Yeah, it actually is really round. And he has many friends. Uellensee, a hexagonal shaped lake. Very interesting. And also that is very interesting. There's a darker region where we have those water veins. I don't think this is any coincidence. There is water already here. So it's just this should continue until here. This is what I mean with these water veins which are drawn in here not being very accurate. Which also means there might be much more of these water veins all over the place which aren't on any map, especially in remote places. And I've been also talking about ice patches in many places on mountains and stuff, like little ice patches, which some of them stay all the summer, even though there is no snow or whatsoever, but the ice patches, they remain. And I think they are fed from below. And because of the composition of the water, its charge, its mineral content, and all these kind of things, it maintains probably this kind of charge that it stays frozen. Like the opposite of geothermal activity. I still haven't figured out how to explain that because I'm no scientist or whatsoever. But this might be, this lake, one example. And check it out, there's like lakes all over the place. And some of them, you can in a way see that they are rather deep. Which is just, to me at least, pointing to them being fed from below. Which also means their outflow, the amount of water and quality, it will all fluctuate. Sometimes there is almost nothing coming out there, and sometimes very much in a short amount of time. This is what I think. If it's in a region where it's cold all the time, permafrost, it might form a glacier. But anyway, thanks.